Hi friends, today we will see about the armature reaction in alternator. So let us consider this is the stator of an alternator and this is the rotor, and rotor has slots in it, and this is the armature winding. Okay, this is the phase A, and similarly phase B and phase C are also present. So I have considered only phase A. Okay, so now the rotor is given DC supply. So here there are currents flowing in these windings. Okay, so let us assume here crosses, that means the current is flowing into the winding, and here the current is coming out of the winding. So as the current is flowing through the rotor conductors, so there is a flux produced the with N here and S here. So as the current is flowing like this, okay, so the flux is produced in such a manner. So here as north pole and here south pole are produced, therefore the direction of the flux will be like this. So the direction of the rotor flux, that is field flux, will be like this. So that is phi f. Okay, let us assume this is phi f. So as it is an alternator, so as we are rotating this rotor, so this flux will be cut by these armature conductors. Okay, this flux will be cut by these armature conductors. So it is a maximum flux here. Okay, so which will be cut by this conductor, therefore maximum EMF will be induced in these conductors. Okay, in this conductors AA dash. So because of the flux cutting, so therefore EMF is induced here. So this EMF is all called as excitation EMF. This EMF is called as excitation EMF. So let it be EF. So we know that this EMF, induced EMF, is always lags flux by 90 degrees. Always lags flux by 90 degrees. Therefore we can draw the phasor diagram like this. This is the flux phasor. So this is the field flux, and this is the induced EMF in the armature. So this is EF. This is the induced EMF in the armature. Now if you connect a resistive load, okay, if you connect a resistive load, so the current is flowing in these armature conductors due to this excitation EMF. Okay, so the produced current will be in phase with this EMF because of the resistive load. Okay, the voltage and current will be in phase, so due to resistive load. So if the current is in this direction, so the flux is also in the same direction. Okay, so the current is produced here. So here let it be cross and let it be dot. So therefore, so if you see, then the flux will be like this. Okay, so here cross will be produced and here dot will be produced. Here cross will be produced and here dot will be produced. So the current is flowing like this. Okay, as the current is flowing like this, the direction of the flux will be in this direction. So this is a phi A, armature flux, because of the current flowing through the armature conductors. So that flux is produced, therefore that flux is called phi A. Now the phi F is like this. So what is armature reaction? The effect of armature flux on the field flux is called armature reaction, right? So the phi F is like this and phi A is like this. So the nature of the armature reaction is cross magnetization. Okay, the nature of the armature reaction is cross magnetization. Is it clear? So as phi A is like this, okay, and it is perpendicular to phi F, therefore it is cross magnetization. Now if you consider inductive load, okay, pure inductive load. So you have connected an inductive load, okay, to the alternator. Therefore this is a flux phi F. Okay, because of this flux there is a EMF induced, that is excitation EMF in the armature conductors. So because of the inductive load, so pure inductive load, okay, because of that pure inductive load, the armature current lags the induced EMF by 90 degrees. Sorry, this is IA. This is IA. The current flowing in the armature conductors lags the induced EMF by an angle 90 degrees because of the pure inductive load. Okay, so if IA is in this direction, then phi A is also in the same direction. Okay, now the phi A and phi F are both in opposite direction. Therefore, the nature of armature reaction is called demagnetization. The nature of armature reaction is called demagnetization. Is it clear? Okay, so if you consider capacitive load, then so this will be phi F and this will be EF, excitation voltage induced due to this flux in the armature conductors. So because of the capacitive load, pure capacitive, okay, the current flowing in the armature conductors will be leading to the induced EMF by 90 degrees. Okay, so as IA is in this direction, so the flux produced by this IA, that is phi A, is also in the same direction. Therefore, these two are in the same direction. Therefore, the nature of armature reaction is called purely magnetization. Okay, this is purely demagnetization and this is purely magnetization. Understand? Now, if you consider some RL load, okay, so this is not pure inductive load. This consists of some resistance also. So this is phi F and this is EF. Okay, so because of this RL load, the current lags some angle. Okay, the current lags some angle theta. Okay, so this is IA. Okay, understand? So because IA is in this direction, phi A is also in the same direction. Now if you resolve this phi A into horizontal and vertical components, okay, into horizontal and vertical components, one component is in opposite direction to phi F and one component is quadrature to this phi F. So therefore, the nature of armature reaction is partly cross magnetization because of this component. Okay, partly cross magnetization and partly demagnetization because of this component, partly demagnetization. Understand? Now if you consider RC load, okay, so this will be phi F and this will be EF. So because of this RC load, the current will be leading to the voltage. The current will be leading to the induced EMF. This is IA by some angle, okay, theta. So if IA is in this direction, then phi A is also in the same direction. Then if you resolve this component into horizontal and vertical components, so one component of phi A is in quadrature with phi F, that is cross magnetization. So the nature of armature reaction is partly cross magnetization and one component is in the same direction to the phi F, so it is partly magnetization. Okay, so this is about the armature reaction in an alternator. If you consider the motor, if you consider the synchronous motor, so in the synchronous motor the current will be reversed. Okay, the direction of current will be reversed. So here the current direction is like this in alternator. Then the synchronous motor, the current direction will be in this direction. In that case also, so it is cross magnetization. Okay, if you consider inductive load, okay, so okay, in the motor the IA direction will be in this direction. Okay, so in that case it is magnetization. Okay, so here the direction of IA will be reversed. If you consider motor, okay, the direction of IA will be reversed. Therefore, according to that, the nature of the armature reaction will change. Thank you.